Alright, so I think I'm recording. Let's take a look at some of these variation problems from Skill 2E. The cost C of materials for a deck varies jointly with the width and length. So when we see jointly, I think multiplication, but I also think that there's going to be more than one variable that follows. So I've got C is equal to my constant of proportionality times the width times the length. If the cost is $470.40, when the width is 12 and the length is 16, that gives me enough information to determine my constant of proportionality, .45. Is that? Alright, so there's my equation that models this problem. Now it wants me to find the cost when W is 10 and the length is 25. So 10 times 25 times 250. So $612.50. Alright, that's what I get. The number of gallons G in a circular swimming pool varies jointly with the square of the radius and the depth. Jointly, we're expecting multiplication, but with more than one variable that follows. We've got R squared and then the depth D. They give me enough information next to determine the constant. Four squared is 16, and 16 times 2 is 32. Oh, so that doesn't reduce. Alright, so my model, oftentimes they call the equation the model, or I do. Alright, so now it's asking me to use this equation to find the number of gallons for a circular pool that has a radius of 3 and a depth of 1.5. So I would assume that's feet, but it really doesn't say, does it? Three squared is 9 times 1.5. So if we just approximate it, 314.3. Over 64. So if we did want, oh hey, that's bigger now. Good. I was having, ah, can will it move to the? Oh, when you move it, it won't. Oh well. An exact value, 314 and 19 over 64 gallons. But the decimal, to round it off is fine. Okay, so here, students don't always like these problems, I guess, because you have to define your own letters for the variables. I don't know. Um, let's let G be the number of girls. Let's let B be the number of boys. T be the number of teachers. It says the number of girls vary directly as the number of boys and inversely as the number of teachers. Now it gives me enough information to determine the constant. So 10 over 20 reduces to 1/2 if we multiply both sides by 2. So my model, my equation is 100 times B divided by T. Alright, how many boys would, if there were 10 girls, 100 teachers, how many boys? Well, 100 divided by 100, there were 10 boys. Alright. Number of students, we can let that be S. T be the number of teachers. A be the number of administrators. So the number of students vary jointly. I'm thinking multiplication, but also more than one variable follows. So I've got S is equal to K times T times A. It'll give me enough information to determine K. 1,000 students. Five teachers, 2 administrators. K would be 100. So then it asks us to use our model if there were, how many students, if there were 8 teachers and 1 administrator, 800 students, right? So I think that's it. So I hope that helps, and I will talk to you later. Bye.